Okay, so this little video is to talk about how you can use NOR gates to create anything. And your homework is to show how you can create anything out of NAND gates. It's going to be very, very similar. So a NOR gate is, it looks kind of like this in the diagram, but we're not going to use a diagram. We're just going to use a truth table. So we're going to have, say, variables x and y, and then x NOR y. And so the inputs can be 0, 0, 0, 1, 1, 0, 1, 1. And in this case, just like the NAND, the 0, 0 gets negated. Okay, and so 1, 1 becomes 0, and that's going to be the same for the NAND gate. But the NAND gate is an extra helpful nightlight. This is just a regular nightlight. The regular nightlight says, I will turn on if both lights are off. There's two lamps in the room. If both lights are off, I'll turn on, and if both lights are on, I'm off. However, if just one light is on, I don't need to be on. Just one is enough. So it's a regular nightlight. So that's what the NOR gate does. And so we want to actually tabulate all the possible functions. I'm gonna pull up another file just a second. Okay, so this is on your practice exam, and it's the same thing on your real exam. This part is the same, this little grid. And as you can see, I've numbered all the possible binary functions that you can have from two input variables, and there's 16 of them, and I'm calling them by a logical numbering system. So for example, function 0 has just all zeros down this column. Well, I'm having trouble highlighting that. Function 1, so if you take these numbers instead of a column and write them out in that direction, you'll see 0, 0, 0, 1, which is 1 in base 2. But if you write 0, 0, 1, 0, it's 2 in base 2. So how does that work? So let me go back to this. If I have this number, like, right, 1, 0, 1, 1, then I just flip it and write it as 1, 0, 1, 1, okay? So that's how I'm converting it. Then I read this way. The far right digit is worth 1, and the next digit is worth 2, and the next digit's 4 and 8. I just keep doubling these purple numbers, 1, 2, 4, 8. And then I add up. The 0 means don't count the 4. The 1s mean go ahead and count. 8 plus 2 plus 1 is 11. Okay, that's the quick and easy introduction to binary numbers. Let me just give you another example. I'm only going to use 4-digit binary numbers. So let's say 0, 1, 1, 0. Like, why are we writing this 0? Well, we don't have to, but we are. Okay, so 1, 2, 4, 8. The zeros mean don't use the 8 or the 1. 4 plus 2 is 6. So 0, 1, 1, 0 base 2 is equal to 6 base 10. Okay, 6 in our notation. So that's just a really quick and easy way of figuring out what the numbered, oh, I did not mean to open that, sorry, I meant to open this. So this is a quick and easy way of keeping track of what's in the table. So every time we stumble upon a new one of these functions, we'll be able to quickly add up, again, like here, how do we know this is function 10? Well, forget that, that's a 1, 2, add in the 2 for 8. 2 plus 8 is 10. Okay, what's this? 1, 2, 4, 8. Forget the 1, 2 plus 4 plus 8 is 14. Okay, so that's how you know, by looking at the column, you know immediately which number function you're looking at. Okay, so what is this? Well, if we look at this 1, 2, 4, 8, the NOR function is function number 8. So function number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 16 numbers because 0 is counted, right? So there's 1 through 15, and then the 16th one is 0 if you want to think of it that way. 8 is the NOR function, and we can check that off because we already have it. Okay? We started, it's a starting value. Okay, and what about x? Just x by itself is 1 plus 2, so it's 3. So this is x, and we started with it. And what about y? 1, no 2, but then 4, so 5. Y, and we started with it. So it was one of the things we started with it. And we started with the NOR gate, so it's essentially what we started. These three we started with. Now, you don't really have to create 0 or 15, but we're going to kind of do it anyway. It's kind of silly, but it's just kind of a fun exercise. Okay, so now we have these three columns that we can, I guess I got rid of this, there we go. We have these three columns, and now we try to combine them. We just mess around until something useful happens. So I can say, for example, F3, which is X, NOR with F3, because that's, I mean, we don't have that much to work with yet. Okay, so F3 is X, this is also F3, so this is F5, and now this is F8. Okay, so F3 NOR with F3, well, what's 0 NOR 0? Well, it's 1, because if the lights are both off, they turn on. If the lights are both on, the night light turns off. So when you take a signal and you actually just split it, like, you know, and you put it through this NOR gate like that, it's just going to act as a big NOT gate. This whole thing turns into, in class I showed you, that's a NOT gate. Okay, so they're equivalent. So that's what's going on. And so we actually have 1, 2, 4, 8. So 4 plus 8 is 12. Okay, so we've got 12. And I'm going to allow you to write a bar over the F3 just to make it easier, because now that we know this trick, that's fine. Okay, you just put a bar over it. It means I took the F3, I split it, and I shoved it through the NOR gate, and what came out was function 12. Great. Okay, why don't we try doing the same thing for function 5? Let's negate function 5, and what do we get? We get 1, 0, 1, 0, which is 1, 2, 4, 8, so that's 10. So function 10 is the inverse of function 5, so now we've got that for free. Oh, we didn't negate function 8 itself. Well, if we negate function 8, we get 0, 1, 1, 1. How much is that? 1 plus 2 plus 4, so it's 7. And so this is function 8 negated. Okay? I guess I should give myself a little more space to say some of these things. Sorry. We'll spread them out a little bit more if we can. Maybe I can't. Oh yeah, I split that 8. How lovely is that? My kids make fun of me for writing my 8s that way. Okay. Anyway, so let's try coming up with some more functions. What do I want to do? Well, I have 3 functions and their inverses, so let me just try crisscrossing. I'll do something like F3 NOR with what is F5 bar, that's F10. So I'll try putting those together. So what was F3? F3 was 0, 0, 1, 1, and F10 we had, which was 1, 0, 1, 0. And so that's going to give me the 0's turned into a 1, the 1's turned into 0, but it's an unhelpful night light. As long as there's a light in the room, it does not turn on. So then we have 1, 2, 4. This position is worth 4. So we now have function 4, which is F3 NOR F10. Okay, so that's a new one, so we got that. Now, what happens if we negate F4? Okay, F4 bar. So we had F4 looks like what? 1, 2, 4, 8. So when we negate it, we get this. So we get 1 plus 2 plus 8, which is 11. 11 is F4 being negated. And if you say, well, why don't I just take 15, subtract 4, and get 11? That's totally fine. You can do that. Because notice, between a function and its inverse, you have to collect all 15. So 1 plus 2 plus 4 plus 8 is 15. So between the function and its inverse, they each get a 1 or 0 in the opposite position. So we have to always add up to 15. Okay, so let's see if we have we checked off everything? Yes, we're about halfway. So what do we want to do now? Well, what did we try? We tried F3 or F10. Why don't we try F5 nor, what's the opposite of F3 was F12, right? So F5 looked like this. We already had F5. It was like that, and F12 is 8, 9, 10, 11, 12. So that's what F12 had to look like. Okay, if we NOR these guys together, we get 0 and 1. It's a non-helpful nightlight. And we get the value 2. 2 is F5 nor F12. And we just said if we take 15 minus 2, we get 13. So this must be F2 bar. So we now have these guys. Okay, great. So we have more things that we can mix and match. All right. I don't like the fact that this is sort of squishing out of its zone. Okay. This thing's squishing a little bit. There we go. All right, I'm a little stumped here. I'm just kind of thinking what I should do. I could pause and make it all work out in a small amount of time, but I want you to see, like, it takes a little time because, and I want to be honest with you about how much time this should take you when you do your NAND gate. So I did this in class, and I'm doing it now, so you get a sense of it. Okay, so we already combined y with something, and we combined x with something. We combined, essentially, we did x and y. We did x bar with y. We did y bar with x. Oh, we didn't do x bar with y bar. So the x was 3, and its inverse was 12. So let's take 12. And then 5's inverse was 10. So I don't think we did these two together, did we? So 12 looks like this. 8, 12. And 10 is 8 and 2, right? So we can put these guys together, and we can NOR these together, which is the non-helpful nightlight. And we get F1. So this is F12 NOR F10, and then 14 must be F1 bar. So we have 14 now, and we have this one. And so what we're missing, actually, we are probably missing, the last thing we're going to probably find is NAND, because it's kind of on the opposite end of the spectrum here. NAND looks like the helpful nightlight. So it turns on even when there's just one lamp. So what is the number for that? It should be, oh, it should be 14. Oh, great, so we already found NAND. That's good. Which means this guy, F1 must be AND. I should have known that. Good, we have AND. Oh, and if this is NOR, this one must be OR. So exclusive OR and its inverse must be the one, some of the ones we're missing. What are we missing? We're missing 0 and 15. Those are kind of stupid ones anyway. So I'm not that concerned if we miss them. Okay, 6 and 9 are probably XOR and the inverse of XOR. So exclusive OR is going to be like that, which is 2 plus 4, which is 6. Yeah, so this is going to be exclusive OR, but I didn't check it because we don't have it yet. And this is the inverse of exclusive OR. So we now have to figure out how to create those. But it should be kind of close to NAND somehow. So the NAND gate, which is F14, which we already have, is ding, 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 ding. Okay, we have F14. What do we want to put it with? I don't know. So let's put it with, I don't know, let's put it with one of our original variables, F3. Let's see what happens. Ding, 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 ding. See if anything exciting happens. We have a nightlight that turns on only when it's pure darkness. It's never pure darkness, so this is going to be off all the time. Well, this is one of the stupid cases I wanted us to stumble upon, which nobody in the right mind would actually build this. Okay, but we got it, and we got this one. There we go. Alright, we still don't know how to do exclusive OR. I still think we have to use NAND as part of it. So I'm going to try with F14 again. ding, 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 and try combining it with something else. Maybe, oh, let's try it with F8, see if that does anything. Alright, so if I NOR these guys together, negate if they're two of the same, then I have a unhelpful nightlight. Nope, not useful. Okay, let's try combining it with something else. Combining it with X didn't help, so combining it with Y probably won't help. Let's just try F12. I have no idea why. I'm just trying random stuff. Okay, so if I NOR this, I'm going to get an unhelpful nightlight. No, we already have that one. Something should do it. Well, here's the thing. We want... What if I have a 0, 1, 1, 1 function? Maybe that would be helpful. What is 0, 1, 1, 1? There's 1 plus 2 plus 4, so it's 7. We do have F7 already, so let's try putting it here. Why am I doing that? Because exclusive OR has an up-down symmetry, right? So I'm thinking if I can flip the 14 upside down, maybe I'll get something useful. Okay, helpful nightlight, unhelpful nightlight. Okay, it's going to turn off, not useful. Okay, but I feel like I'm onto something. I'm going to stop using F14. I'm going to try to use, instead of F14, let's try F8 and see if we can flip F8. So this whole thing I could have done off out of your, you know, line of sight. I could have done that. And you would think that it was easier than it is. I don't want to lie to you. I don't want you to think that it's easy. Aha, I got it. Okay, I mean, it is easy in the sense that eventually you'll stumble upon it, but it's not easy like the very first thing you try works. Okay, so I want you to know that the very first thing you try probably won't work. You've got to stumble around in the dark a little bit till you get the thing you need. And this is a correct exclusive OR. Okay, and so this is F8 NOR F1, and so we finally got it. And then the opposite of that is going to be F6 bar. So we've got it. We got all of them. Okay? And so what am I going to do with this? Well, I just proved that the NOR gate can be used to create any function I want. So let me just give you an example. I mean, you can stop. If you get it, you can stop. You can stop any of these videos. You don't have to watch any of these videos. Okay, but if you're listening still, and what this is saying is I'm going to just pick something. Let's pick, okay, this one looks kind of complicated. I want F4. And F4 is going to have a truth table that looks like this. X, Y, and I don't know what at the end. So you're going to have, what's X and Y? X is F3, and Y is going to be F5. So I'm giving them duplicate names. And I want to build up until I get to F4. F4 came from F3 and F10, but F10 came from the inverse of F5. So we need to invert F5 to get F10. Okay, so we have this column. And then, yeah, okay, so we have F3 NOR F10. F5 inverse equals F10. Okay. And then the next column is going to be F4 is equal to F3 NOR F10. So I'm going to look at this column and this column. Okay, 0 and 1 is, okay, so nightlight will not turn on. 0, 0, pure darkness, the nightlight will turn on. 1, 1 is already really bright, the nightlight will turn off. And there's some light, so the nightlight will turn off. So I've just demonstrated how to create F4 using NORs. And you may say, but you used a not. But we had an exception. We allowed ourselves to use not because what we could say F5 NOR F5 equals F10. But it's easier to just say F5 bar equals all that stuff, because it just takes less time. Because every time you need to negate, you just NOR something with itself, or you just NAND something with itself. So just to save yourself effort, then you're good. Okay, so I guess that should be helpful, I hope.